All right, good day, everyone. Give me a second here. It's going to move a couple things around so that I can see everything on my desktop. All right. Good day. My name is Jason Strait with the Cloud Pass Virtual Group. Our presentation today is Google Cloud Platform and Introduction. And our presenter is Mark Mucchetti. And before I get things going today and I hand it over to him, I'm just going to go through a few announcements. First, the Pass Cloud Virtual Group is sponsored by Microsoft. Microsoft sponsors the group to help us have the ability to do these presentations and to help drive knowledge around developing out cloud data platforms. If you are not already a member of our virtual group and you just kind of rolled in here and didn't know much about this, we do have a cloud.pass.org website, and on that website you can subscribe, and when you subscribe then you get the newsletter and you find out about all the different presentations that are coming up. I try to have 2 presentations a week. This week we'll actually only have 1, but most weeks I try to have 2, try to make sure that people have a good opportunity to learn a lot about cloud platforms. I think last year we had 65 presentations throughout the year. Speaking of presentations, though, we do have the 5 more that are in the queue. I've got a couple others that I'm working on rescheduling due to some speaker illnesses. So I do expect this to jump up to about 10 to 15 presentations in the queue fairly quickly here. But if you are interested in speaking, I do recommend just reaching out to me. You can reach out at cloud@pass.org, or you can go to the form that's on the cloudpass.org website. And I tend to check up on that every few weeks to make sure that everyone that has submitted anything has a chance to get their session scheduled. This virtual group is part of a number of virtual groups that PASS helps to support. These focus on different languages in some cases, like Global Chinese and Spanish. Others focus on different aspects of building out data platforms like high availability and disaster recovery or PowerShell. Just different ways that you can go about learning more about building out data platforms. Throughout the session, if you have any questions, please type them into the Q&A panel. And then at the end of the session, time permitting, we'll go through as many of the questions that we have time for. And that is all the announcements that I have for today. So let me hand things over for our presentation today, Google Cloud Platform and Introduction. And I just got to get to the right spot here. There we go. All right, Mark, you are now the presenter.
Hi, everybody. Welcome to this presentation. So today what we're going to be covering is a very broad introduction to Google Cloud Platform. So it'll start a little bit slow and then it's going to go pretty fast, and then it's going to skip a whole bunch of stuff. Quick background on myself. So I've been a professional engineer for about 20 years. I've kind of done all of the different roles in the practice. So I've done some release and some SQL and some IT and engineering. Right now, I run a development shop that is mostly in GCP, also in AWS, and most of what we do is serverless using Node.js and C#. I'm based out of Los Angeles, specifically Santa Monica, and you're welcome to add me on LinkedIn if you like this presentation. So the presentation here is a very kind of top level introduction, and the reason that is because it's very difficult to cover all of the capabilities of GCP in a short amount of time, and there are so many. I gave this presentation a few months ago, and I did a show of hands in the audience for how many people had even worked with cloud technologies, and I think maybe a third of the room had raised their hands. So it's kind of interesting, just how much is out there and all of the varied levels of understanding of what's available and all the different things that you can do. And so the purpose of this presentation is really to just kind of do hands-on end-to-end, look at a little bit of everything. And as we go through this, hopefully something will strike your interest and you'll want to do some more research. The Google documents are generally pretty good, but sometimes it can be hard to find the exact thing that you're looking for, or as you're starting to go through an actual use case, Sometimes it can be difficult to find the thing that addresses your specific use case. Stack Overflow is also pretty helpful in this area, as you might imagine. So with that, let me just do a very broad summary of what's available in Google Cloud. Another learning I've had in the last couple of years, and I think the Google people I work with will forgive me saying this, is that the marketing itself has not always been so great. And so whereas with AWS and Azure, you can generally see what the capabilities are and you understand where there's parity and you understand where one might be better than the other. Google traditionally had not done that as well. The console was also sort of difficult to follow. They've fixed that. It looks a lot like Amazon now too. But I think it's kind of important just to talk about all of the different things that they have. The first surprise people have when they learn about GCP is that it started in 2008. The first service that they offered was App Engine, which predated most containerization techniques and was pretty old, but ran on what Google already had, which was also interesting because one of the reasons that Google's marketing took a little bit of time to catch up is because their technology 10 years ago was somewhat ahead of what a lot of the other cloud providers were doing, but their customers were saying, we want virtualization, we want machines in the cloud. And so Google went along with that and built Google Compute Engine and App Engine and so forth. But they already had the underpinnings of what would become Kubernetes. They already knew about containers. They already kind of understood how to do it, but that wasn't the direction they went because the market wasn't totally ready for it. Once Amazon started rolling that stuff out and they were in deeper competition, they realized that they already had this stuff. And so they started to double down on some of this. And now they pushed into serverless in the same way. And with Cloud Run, they're moving into serverless containerization, which sounds a little bit like an oxymoron, but it's kind of an interesting technology too. The primary conference for this is Google Next, which generally they'll cover deep sessions on all kinds of things, all the services. They're also releasing new services all the time, so it's very difficult to keep up with all of the announcements. And most of us don't try, I don't think. So just a broad overview of all the products. I have the link to the entire product sheet. If you want to check that out, it's pretty extensive. But the way that they group things is typically in compute, data analytics, databases themselves, networking, virtual networking, security, and identity, and then they're underpinning all of the storage components. And then they've invested pretty heavily in AI and machine learning and a lot of those things. So you'll see some pretty robust capabilities there in the AI space. And that's growing pretty quickly too. It's starting to get into the realm of accessible to most people, I would say, or that it's easier to build models. We're not going to do ML directly in this demo, but I'll point out a couple of places where it ties in. And certainly as we go, you'll see it in action. They're also starting to push pretty heavily into the multi-cloud area. As I mentioned earlier, we do a hybrid workload between GCP and AWS. And so there are some interesting things you can do with getting stuff between those systems. Google's also trying to power on-prem and kind of get this Cloud Run technology into a lot of different areas. So that's probably an interesting area of development we'll see in the next couple of years. So hopefully there will be something here for everybody in some of these areas. I'm going to drill down a little bit so we can get into our actual exercise and demo, and you guys can actually see what some of the console stuff looks like and how we're going to build an application. So in the compute area, I mentioned App Engine already. The Kubernetes engine is, the Kubernetes orchestration for GCP. Cloud Run I mentioned as well as the new serverless version of containers. Compute Engine is the more traditional virtual machine. So if you're familiar with EC2, it's relatively the same thing as that. And then Cloud Functions is the serverless version of functions as a service for GCP. If you're familiar with AWS, it's roughly the same as Lambda. There are some interesting differences in runtimes that are supported and things like that, but you can kind of consider those to be one-to-one systems there. So then moving into the data side of the house, data is really interesting here too. Google has a whole bunch of stuff, and their rubric for figuring out which of their services you probably need is also really fascinating, depending on what kind of scale you have, the global workload that you're trying to deploy, or it's not global, you have traditional relational, you want NoSQL, you want to do distributed, all of these different technologies are supported in different ways. The three that I'm going to call out specifically here are Cloud Firestore, which is the NoSQL distributed system that they use for database. It was originally a Firebase product, which is why it's called Firestore, but now it's been migrated into GCP itself. Cloud SQL, which is pretty similar to RDS and Amazon, if you're familiar with that, or Aurora a little bit, which does your regular Microsoft SQL Server, MySQL, Postgres in the cloud. And then BigQuery, which is kind of my personal favorite. So BigQuery is GCP's data warehousing technology. They support analytics at a really high scale. It's really fast, super reliable. And if you've ever built out data warehouses or OLAP workloads or any of this, just the amount of stuff you don't have to do to get started with BigQuery is pretty fantastic. So we will be going into some of that throughout this presentation as well. I mentioned the AI ML side of the house. There's a ton of stuff here too. Google's starting to leverage a lot of the technology they use across their own platform to do all kinds of machine learning tasks really quickly. There's all kinds of like object recognition systems. You can leverage the translation they use on their own properties. There's a lot of auto predictive models. BigQuery has an ML function that lets you do machine learning and predictive analytics kind of directly from your data sets. And then Dialogflow, which is what we'll be using in today's demo, is the chatbot or kind of Google Assistant technology. They acquired Dialogflow a while back, and since then they've been using it to build all kinds of interesting experiences across voice and text and so on. And it's pretty well integrated now too. So you can kind of build multiple experiences using the same code. You don't actually have to write a lot of code to do that. So we'll get into that a little bit as well. So today's guest star is Bort. Bort is an avatar for a chatbot that we use in our own tech department. The concept for Bort was really, you're on Slack all day long, and every once in a while you forget something. You want to know what an ID is, or what's this primary key, or what is this piece of data. And somebody will post it in Slack, and then someone has to go look it up. The idea is that Bort is kind of like a virtual employee, and so it has access to all of the different systems and all of the internal data pieces, and it can go and retrieve those things and report back to Slack pretty quickly. It has a couple of interesting side effects. One is that if everybody can kind of see it in a channel, then they're more likely to accept it, if that makes sense. So if you need to see a particular piece of data and then it gets posted to the channel and everybody can look at it, that can be pretty interesting. It can drive a lot of consensus a lot more quickly. Also, I'm a big fan of chat ops. We spend a lot of our time in chat, and it's nice to be able to stay in that context when you're trying to learn things about your system. So we also use Slack integrations pretty heavily. We use a lot of chat ops to push things through. But I really like this as an example for the capabilities of GCP, because you can build it out really quickly, and it's all serverless. And so you don't have to worry about uptime or reliability or anything. It just kind of works. And so what we're going to be doing today is really just build this system out in a very bare bones form. So you can kind of see all the technologies that are involved in doing that and how easy it is to kind of do your own. And that's, again, it's not an exercise, but to the point of the exercise, it's really a jumping off point for you to see other technologies that you might find interesting. So this is a typical conversation that someone might have with Bort. He has a lot of small talk and other routines built in. It's tedious to do it, but it's kind of fun. It sort of lends a little bit of personality to it. So a couple of caveats before we get started. This is just a demo, so it's not going to have all of the production characteristics that you would want in a fully working system. So we're not going to be putting any additional security into the system. So GCP automatically will provision keys and it will set up connections between the various services to make sure that everything is secured within the boundary. But if you're going to build your own code and you're going to have it accessing your own systems, you're going to want to do more work there, especially if you have it integrating outside the system. Also, if you're going to be doing anything that is going to transfer data over the public internet, you're going to want to use your normal encryption and SSL. Also, one other thing I'm going to do is we're going to do this entirely in the browser, mostly because it's easier than dropping to code in the middle of sessions, but also because it is kind of cool that you can do everything without actually dropping to code. So if you were actually building this system, you would want to use projects for all of these various things and have your code committed, and you'd want to do your normal software lifecycle management here. We're not going to do that. And then lastly, we're not going to build a lot of the conversational interface. If you guys are interested, I leave it as an exercise to you. It's pretty easy to do. It just takes a while to supply all of the phrases and to make it all work properly. Dialogflow has a pretty good default model that it uses. And so, I mean, it kind of can answer basic questions, but you can go pretty crazy with it if you want to give it all kinds of stuff. So let's talk a little bit about how it's set up on GCP itself, and thus what kinds of services we're going to look at. So cloud storage is really the basic GCP service. It's what you would expect. It's a bunch of storage that holds your files in buckets. And so anything that you're doing in a GCP project is going to interact with cloud storage in some way, because eventually all of the functions and everything you're running are all stored somewhere in your project. We're going to use BigQuery so we can go into how the system gets data. So if you want to interact with your data analytics and you want to do it directly in your chatbot, you can connect all of that in. We're going to run all the compute through Cloud Functions. It's very easy to do, and Dialogflow supports natively loading Cloud Functions to support its own fulfillment. So that's very simple. You could do any other system for this. Essentially, it's just an API that uses JSON to communicate. And so you can use App Engine or Compute Engine or Cloud Run, or you can use EC2, or you can build your own system. You can use Heroku. I mean, you could do anything to build the functions. The JSON schemas are pretty well documented. Dialogflow I already talked about. That's just kind of the system that pulls it all together and creates the interface to chat. And then Stackdriver, which is kind of the whole monitoring system. Again, for AWS people, it's similar to CloudWatch. It pulls in all the logs, all the consoles, all of everything, all the error logs. You can set up tracing and debugging. Stackdriver is also a relatively recent integration into GCP, and in fact, they're kind of bringing all the interfaces together. So within even the last couple of weeks, a lot of that UX has been changing on the Stackdriver side. So I think all the stuff we're going to look at today is still pretty similar, but there have been some interesting changes in monitoring. So a quick diagram for all of that, just so you can kind of see how it all fits together. Cloud storage and BigQuery on the left as the data sources, the Cloud Functions right in the middle, everything logs to Stackdriver, and then Dialogflow pulls from the Cloud Function and also from its own system. And then, as I mentioned, and we'll look at in a little while, Dialogflow pushes its chat data to whatever other integration you want. Again, you can build your own directly against the API. It also supports a bunch of native integrations like Slack, Google Hangouts, and we'll just be using the web demo version for today. But you can also pretty much just as easily tie it to a voice experience. So you can tie it to Google Assistant. You can tie it to Twilio if you want it to work as an IVR kind of system. You can tie it to, I think, Twitter and even other systems like that if you want it to respond in other ways. So it's a really interesting way of doing natural language processing and conversation through a pretty united system. And I think at this point, there's a lot of virtual agents and chatbots that are using this system, and I haven't heard a lot of people talking about it, so I'd kind of like to bring it in here as well. All right, so we're gonna go into the demo here. I'm gonna switch my screen share to Chrome so you guys can see what we're working on here. And you should be able to see that now. And let's, no, that's not what I wanted. And let's get started on this. So what you're looking at here is the primary console for GCP. This is what you see when you log in. And on the left side here in this nav, you're going to see all of the services that you have access to. So if you go to a service that you don't have at the moment, like you just pick some random service, typically it's going to do something like this. It's going to spin up a new system for you, and then it'll load and show you you can apply it. And that's true for basically everything else in the system. So you can get into all of the stuff in this system pretty quickly just by kind of clicking into it and seeing what it is. And so you'll see they all kind of just start. So I'm going to briefly address the cost part of the situation. So there is an always free tier. You can do a low workload more or less for free. Some services will require that you set up an account. You can usually get some sort of free trial, so you can check things out. And the costs, if you're using serverless, the costs are going to be pretty linear to the kind of traffic you're getting, so it's going to scale pretty well for you, and it's not going to cost you a whole lot of money until you kind of get into it. I will say with respect to BigQuery, BigQuery can get fairly expensive if your workloads are getting very large, but in the small sense, it's not going to be too much to worry about. So you'll know when you have to enter a credit card, so don't be afraid to kind of get started and see what's in there and what interests you, and hopefully you'll see something that you find interesting. So I mentioned the services we're mostly going to be using today are going to be over here in the left side. Just a couple of call outs based on what we just covered. Compute is all organized together, and then all of these storage methods I was discussing, and even a couple of other ones are listed here. We didn't really cover the virtual networking piece of this too much, but you can do all of the stuff you would expect around CDN and VPCs and connecting systems together. And then the ML is kind of starting to come into that system as well. Stackdriver we discussed already. And then there's a huge amount of development management tools. So there's actually a fully integrated source control system. You can store your code in a Git fashion using GCP, and you can set up triggers to auto build. So if you are starting from scratch and you want to do a continuous integration deployment pipeline, you can actually do that pretty easily entirely within GCP. And that's actually how our production version of Bort works too. We tested using, instead of GitHub, which is what we normally use, we tested using Google to store that code as well. And so there are some pretty interesting things you can do with that too. And then we mentioned big data. BigQuery is classified as a big data service because it's designed for analytics workloads. We're going to be using it more like a transactional SQL today. That's kind of an anti-pattern in the production world, but I want everybody to kind of see how it works. And then, just a ton of other stuff. Another thing I didn't mention is that G Suite, which is Google Docs and Sheets and Gmail and kind of all that stuff, their enterprise system is not technically part of GCP. But you will kind of run into connections between the two. As you're setting up seats and identity management, you're technically using G Suite to do that. There's also a fair amount of connections between Docs and Sheets and so forth and the actual GCP services. So if you want to run a BigQuery workload off of GCP, or sorry, if you want to run it off G Suite, you can do some of that. There are some connections there as well. So, okay. So let's get started. We're going to work from back to front here, so you can kind of see all the different services that are built up. One nice thing on my panel is I can see which resources this project is currently using. So you can see that it's got the storage buckets that it has automatically provisioned, the cloud function, which we use to power the intents, and then the data set in BigQuery. So we'll start in BigQuery here. So this is the console for the BigQuery system. BigQuery's been around for quite a few years now, but they had an older system that looked kind of like old Gmail that they've either have already deprecated or about to. So if you looked at it in the past, it might not have looked too much like this. The concepts in BigQuery are pretty straightforward if you're familiar with SQL or data warehousing. This is the project, and then this is the data set, which you can roughly think of like a schema. It's not quite a schema, but it's kind of a collection of tables. And then these tables have standard SQL. BigQuery is fully standard SQL compliant, and so you can run any normal SQL statement against it. You can do a lot of other stuff too. Again, if you had used BigQuery in the past, there was a non-standard dialect of SQL that it had previously used. That's been deprecated, so now it's entirely using standard SQL. One other thing that I didn't call out on the main page, but I'm going to do here, is this Cloud Shell. The Cloud Shell is really interesting because it's the same as running gcloud from your terminal. So if you're just doing regular command line access to GCP, you can do it through terminal, or you can also do it directly in the browser. And what it's doing right now is it's spinning up a virtual machine inside my project that I can actually do, that actually has all of the identity associated with already, and I can go and look through all of my projects. I can do essentially everything from this command line. I can run BigQuery queries. I can connect to things. I can use cloud functions. I can do kind of everything. So I just bring that up so you guys can kind of see. You don't even need to leave the browser to do that. So this is pretty useful if you're. This is just a regular Linux. And you can learn about it there. It does point out that it is ephemeral, so you don't want to leave any long-running processes running on that. They'll get killed at some point. But just for doing quick queries, if you're more comfortable in the terminal, it's pretty great. So looking at BigQuery, what I've done here is I've created a table called test1. And test1 has a pretty simple schema. It's just a question and an answer, which we'll talk about in terms of knowledge discovery. And I can just do the normal piece here. So you're going to want to get your table. And then for some reason, you're going to want to change this to a dot in this context. And then you can just run this here. And then you'll see that I've got a question and answer already in here. The question is, who are you? And the answer is port. Pretty simple stuff. And then I've just got 2 questions in here already. So I'm going to go ahead and show you guys looking at this schema one more time. So you can add fields through here, and you can also configure. You can configure how the fields work. You can change things. Like any data warehouse system, you don't necessarily want to be changing this stuff a lot, but far beyond the scope of this particular tutorial to kind of get into that. So we can also create new tables here, and I want to call this out because there's a lot of different ways you can get data into BigQuery. You can do loading. You can also do live streaming. You don't have to worry about the amount of storage you're using. There is a cost associated with it, but in terms of the actual system provisioning, it could just keep scaling and scaling and scaling. And you can do petabyte level queries in a relatively quick period of time. It's really fascinating tech. We could do a whole session. And in fact, I've done whole sessions kind of just on some of this stuff, but I want to kind of move through everything. So I'm just briefly touching on all of the different pieces of the system. So you can make an empty table. You can just provide a Google Cloud Storage bucket to do it. There's a ton of ways you can import from other data warehousing systems, or even from kind of less structured data pieces, or even if you have a comma separated list, all kinds of stuff. You can also just upload a local file. So if you're normally going to make a table, we're just going to make a table called test2. It's very creative. Just your normal kind of SQL information. We'll do the same thing here. We'll add a question field and we'll add an answer field. And then because it's a data warehouse system, you can do partitioning based on date grain. There's also a relatively new feature that may still be in beta where you can partition by integers. So if you're going to run really large workloads, you're probably going to want to do some stuff like that. Again, documentation is pretty extensive. So you go ahead and make this table, and then you'll see that it's been created here. So your typical normal SQL things that we can query it and add data and so on. The other pieces that are interesting here are this piece, which will tell you how much data a particular query is going to use. This is relevant because Google bills a nominal amount for the storage, but mostly what they bill for is the amount of data that your query processes. So that's not like how much data comes through the server to your browser, it's how much data is actually being touched in order to generate the query. So if you have a giant table and you are accessing all the columns, like you're doing a select star, you're going to use a gigantic amount of data and it's going to have a measurable cost. But this is going to tell you about that before you get into that problem. The other really cool thing about BigQuery, I mentioned that it loads unstructured data from other places. Another thing you can do is you can just point directly at public data sources. And there's all kinds of stuff that just comes into your project when you start. Also, if you're familiar, if you're not familiar with Kaggle, I definitely recommend you check out Kaggle. They have a ton of free giant data sets with all sorts of things. Google's pretty strong on understanding that building real insight about information comes from having lots of different sources to tie together. And so the more data you can pull in, the more interesting your insights can be. The basic example is if you are running a retail store business and you're looking at foot traffic patterns in the store and you want to know what caused something, you can just directly from here, you can just pull all of the weather data. So you can see like maybe there was a tsunami in the area that day and nobody came into the store. But I mean, realistically, it has all of the historical weather dates and data as well in these data sets. There's also all kinds of other stuff around genetics and blockchain and so on. So, and you can also point at any other data set you might want to use. You don't even have to kind of load it into your own system. You don't have to copy the data. You can query it directly from the public data. BigQuery has a lot of interesting sharing capabilities where you can make your data sets available to other users. You can make your projects available to other users. You can recently, you've been able to start doing scheduled queries. So you can do ETL on a regular basis. They've been pulling out Google Data Studio. They recently purchased Looker, which is a data analytics and dashboard company that is going to start tying directly into all of these things and does. So the world is really remarkable. Again, I think it's probably clear, why this is my favorite service, but definitely check it out. So moving up into the Cloud Functions area, this is how we're going to get data out of BigQuery to supply to the chatbot. So you can look at this Cloud Function here, and you can see kind of all the errors that I had while I was building it. And you can see the way to get to it. So if you copy this and run it in your browser, if you do it right now, I'm pretty sure it will just tell you that you didn't post the right thing. But it is currently a public URL. And then you can read the source code for it and edit it directly in here as well. But we're going to do that on the Dialogflow side. So the way that this works is that when this function is deployed, it sits out here at that URL and it waits for you to call it. And then when you call it, it magically spins up a container, essentially, in which it's running a tiny version of this function, and it executes this function and then it goes away. In reality, it probably continues to persist, but the idea is that the unit of execution here is a function, and you don't have to worry about what it's running on or how it's running. All you need to worry about is the runtime you built it in, and sometimes you need to worry about how much memory it's going to use. So then if we go to Stackdriver, which I mentioned earlier, this is the logging for everything. So you can see in this log right here, this request that I just made, which did not work. So the function execution started, and then it realized that I didn't supply anything, and actually I didn't even use a post verb, and so it crashed. Crashing is okay with respect to Cloud Functions because they're just kind of living there by themselves, so it's just gonna build it up again. There's no there's no penalty, so to speak. Okay, so now we've looked at kind of how we've gotten our data into our system, how we're going to call the data out of the system. Let's move into Dialogflow itself. So first of all, you'll notice that Dialogflow has a somewhat different view than the rest of Google. While it is a GCP property, it still retains some of the look from before it was acquired. They've been kind of making it more and more integrated as they go on. So the primary concept here is the concept of intent. If you've ever built for Google Assistant or Alexa or any of those systems, or even Android, you'll recognize intent as the way of translating what I'm asking into some sort of natural response. So it tries to figure out what I'm asking and then supply the appropriate response for that system. And so we can make an intent here. We can call this intent GCP. And then the training phrases are just like, what are some things you would say to make it create this intent? And then like you could say something like, do you run on GCP? Are you a GCP bot? How do you feel about Google Cloud Platform? And so on. And when I go ahead and then you can specify the response that, I run on GCP. I am part of a demo. I am running a GCP demo. And you can go ahead and save that. When you save that, it's gonna save the intent here and then it will retrain the model so that it begins to recognize this system. And training is very fast right now because we have so few intents. It starts to slow down kind of as you go. So now we have a chatbot, essentially. We've already done all of the work here. So if you go to integrations, you can see all of the different things that you can integrate to. A couple of these are missing because I am not in a G Suite connected account right now. So normally you would also see Hangouts, and there are a couple other things you can connect to. You can also, as I mentioned, build your own. Phone gateway is really fun. You can just make it a phone number and you can call it and it just enables the voice experience right away. We're just gonna do web demo so you can just see what it actually looks like. So if we turn this web demo on here, it'll just give you code to put an iframe on whatever site you want. But we're just gonna go to the GUID system. So this is our chatbot. This is the frame you would see if you embedded it on a site right now. We can just say hi, and he's already got small talk built in. And we can say, do you run on GCP? And he'll say, I'm part of a demo. So this is already receiving this intent properly. And it will also have some pretty good responses to things that are not directly related. So if I say, are you GCP? I'm going to say GCP is great and do all these things. It's going to know that that's the intent I'm looking for. So then likewise, you can go back to this intent, this GCP intent, and you can run ML on it automatically, so it'll kind of learn its own training phrases. And you can also, this is where it starts to get complicated. You can tie it to contexts, so you can make it give certain intents when you're in a certain part of the conversation. If you wanted to build an entire conversation flow, you could also add follow-up intents. So as you're moving through this conversation, it's going to ask another thing and kind of keep you going. So you can build pretty complex conversational trees using this system. I will say that I've done a fair amount of work kind of on the Alexa side of the house and building Alexa applications, and I found this to be a lot easier to kind of understand all of the trees that you need to build. And because you can do this all in the browser as well, and you don't have to drop the code until you want to get somewhat complicated, you can get a lot done directly through here. One of the new features is knowledge. And this is kind of cool because you can just give it all kinds of random documents and it will automatically kind of build from those documents. So you can load a file from cloud storage. You can just load a URL directly and it'll just load some stuff into the system and begin responding. So there's all kinds of stuff you can do without dropping the code is what I'm trying to say. But let's look at the code. So if I go to this entity here, and sorry, if I go to this intent here for test one, and I scroll down, you can see I have no responses, but I have something called webhook call for this intent. So what that means is that when this intent is recognized, it's going to fire a webhook. And that webhook is going to fire to the cloud function we were looking at before. So it knows that because the training phrase says, please give me the results for test one. And test one is an entity that I have defined as anything in the system. So when you ask it something, it's going to parse the rest of the question as the question that you want to ask. So you can say, please give me results for who are you? And then it'll say the answer to who are you is Ford, which, as you can see, was originally what we stuck in this table. So what happened when I tested this system, or again, we can see directly from this chatbot, it'll do the same thing from here. So what happened is it goes through this fulfillment tab, and it runs this cloud function. So it'll give you a default cloud function when you start loading it that doesn't really do anything, but you can build it out pretty quickly. So let's go through this real quick so you can see how that's working. So it has a reference to BigQuery itself, and then the function that is exported here is the fulfillment function, which takes the request from the chatbot, so from here, and then we'll create an agent with it, and then you can add whatever systems you want, whatever functions you want to the agent. So obviously this isn't very good code, it's not properly factored or anything, but just as a demo, you can drop all your functions into this main index.js. So then what it does here is pretty simple. It builds the BigQuery object, it loads this data that we were just looking at, it feeds the parameter in that it parsed from the question, and then it runs the SQL query. Again, don't ever do this because there's all kinds of SQL injection vulnerability risk here. But it'll run that question directly against the BigQuery and get the answer and then supply it back. And it knows to do that because down here I have mapped the test one intent to our BigQuery function. So what that means functionally is that this table now connects directly to the chatbot. So I can do something like insert a new response. That's probably a bad one. We can say pass. And then we can do this. And then we can run this query. And then it can take a long time. And then you'll see that that inserted the row here. So now if we do the same response, you'll see that it has this. And then if I ask it the same question over here, it doesn't know the answer yet. Interesting. Well, that's the risk of doing a live demo, I suppose. So what we can do, and this is where Stackdriver comes in handy, is we can see what actually happened inside the request. So we can see that the host supplied what looks like a proper request. You can see question and you can see the intent here. And then you should be able to see the parameters, but you can see it looks like the question, it thought the question I was asking was, please give. And probably the reason for that is that I did not supply, for some reason it thought that I was asking a different question. So we'll try it here, and then you'll see that it is improperly giving the wrong question here. So normally this is where you would start debugging through the system and kind of trying to figure out what the problem is. So you can also see, yeah, so it doesn't know. So we can try something like this. We can add a new training phrase. And to do that, we'll put this here, and then we'll do the same thing. We'll fill in this question, and we'll save this response. So now it'll retrain the model. There we go. So now with this new training model, it has figured out what the proper response is. So if we do the same thing here, we'll get this answer. So that's pretty much how all of that works. I'll call out a couple of other things here. I mentioned entities briefly. So entities are kind of what we were just looking at, but you can build your own. So if you wanted something that belonged in your actual system, like orders, you could put a group of entities called orders, and then orders maps to something called orders. And if I say order, I might also want orders. If I say invoice, I might want orders, and so on. And so then once I build one of these, I can go back and look at the same intent. And I can say, no, I should probably do this. No, this one. I can say this is now an order. And so then when it reads GCP in the system, it's going to think that that's the parameter. So you can kind of do your own system if you want to build something that understands objects that are native to your own business domain, and so forth. So if we jump back to Stackdriver again on here, we can see all of the other things that we were calling. We can see all of the other responses that have come out to the system so far, and kind of all of the various questions we were asking. So this is pretty useful in terms of you can really see all of the traffic, and you can also see all of the console logs if you want to drill down into specific tools. Like I'm looking at this particular cloud function, and I'm just kind of looking at everything in the system. It'll start to build all kinds of analytics around your logs, and you can also create a sync directly to BigQuery. So by default, Stackdriver is not going to save your logs for longer than 30 days, but you can actually pipe them right back into BigQuery and keep them forever. And then you can build more stuff with BigQuery, and you can kind of go forever. And so we can also say something like this. No, that's not the full. And then we can make sure that this row is inserted properly. And then we can say, all right, so that's pretty much all I got today. Hopefully you saw something that you liked in the demo somewhere. As I mentioned, there's so much more we can do with this system. There's so many more services that we could just put into the system pretty easily. So PubSub is worth noting. PubSub is kind of like SQS if you're with Amazon. You can do queuing. You can also have Cloud Functions in BigQuery work directly against it. So if you need to run some kind of queue, it's pretty simple to set up. It's also serverless. BigQuery ML is really fascinating. Again, you could do many sessions directly on it. Using the data that you've stored in BigQuery, you can run predictive models directly against those data sets. So you can do all kinds of modeling without really knowing a whole lot about how the model is built. If you Google the ml.predict or models or BigQuery ML or BQ ML, then you can see all kinds of other stuff. And they're improving that on a pretty regular basis. So that's a really interesting area of development. So hopefully this was instructive to everybody. I really appreciate everyone's time. And I think, Jason, we can open it up to questions.
All right, great, thanks. Mark, this has been great. I personally haven't had a lot of time to dig into the Google Cloud, so this has been a great way to learn a little bit more about it. We do have one question so far queued up, and that was that this is what is validation in the dialog flow? Okay,
so let me jump back over to Google Chrome here. So validation is a feature that they added pretty recently. to allow you to see if there's problems with your intents. So what happens with so our version of this in the production environment has like 200 or 300 different intents, and sometimes the training phrases get mixed between intents. So it'll tell you things like you don't have enough training phrases, or you've got problems where the same question is leading to the different answers. And that can be a problem if you have a lot of top level intents. So I guess a really basic example would be a user wants to know if their flight is delayed, but if they ask the training phrase, is my flight delayed, it's mapping to both, flight delays or flight purchases, and so it's going to get confused. I actually just recently used it in our production version to resolve a bunch of the conflicts we'd seen, because the system was starting to give kind of arbitrary responses, and it wasn't answering questions it was supposed to answer. It was like giving attitude instead, which is, as you imagine, kind of a problem.
Right. All right. And that was, looks like that's going to be the only question we have today. So thank you again for presenting, and thank you everyone for attending.
Thanks, everyone. Have a great day. Good night.
Yep. Oh, go ahead. All right. Well, thanks all, and have a great day.